Great that you're all here. So I hope you're all excited to be here. I hope you're excited to learn about all the new products and services and features and all that here at reInvent. Is anyone excited? I saw you could raise your hands. I saw that earlier. Yeah, there you go. That's one. And tell me again. Just, no, indeed, raise those arms. You're going to be doing this a lot of times this week. But who here is excited to use those new services and features when they get back home or back at the office, of course? But who of you also has some rework that needs to get done? So who here has a backlog, who'd like to use those services, but still there's something to do? There you go. All right. This is Matteo Palazzi, and I'm Chris Nylander. Oh, sorry about that. We're professional services consultants for AWS Professional Services. And as consultants, we're working on the clock, and we need to get things right the first time, every time, quality, security. But it's not only us, it's the team as well. So it's partners, it's customers, it's you. And today we're going to show you how we do and how you can accelerate your code delivery by using development containers with Amazon AI Code Assistants. But before we get into that, I just want to know, so are there any other consultants here as well? No? Engineers?
One.
Oh, one. Okay, we got some engineers as well. Have we got my security people as well? Oh, wonderful, wonderful. But actually a more important question, is there anyone here already using development containers? Good, good, good. Well, no worries, we'll go through the basics as well, so everyone's on the same page. One final remark, this is a code talk, and I don't know if you've done a code talk before, if you've attended one, but it's like a long live demo, so we'll be doing coding and stuff like that, and yeah, hopefully you'll enjoy, but it's also interactive, so if you do have a question, we'll try to pause every now and then so you can pop one in. And if we can't answer it, then you can approach us afterwards. That's also fine. Cool. All right, first thing, I really want to make sure we're all on the same page here. So let me set the stage. So I want you to imagine that it's Monday morning, maybe the Monday after reInvent, and indeed you're excited to get to work to try those new services and features. But remember that pull request you had from last week? Yeah, it got rejected. And as you're getting ready to fix it, to mend it, now you have security reaching out over Slack that they found an overly permissive bucket and you need to drop everything and fix it? All right, now it's Thursday and you're everyone's hero. You mended your PR, you fixed the bucket, but it is Thursday already and your sprint commitments are in serious jeopardy. Does that sound plausible? I see some nodding heads. That's good, and it should, because 45% of production deployments actually require rework. It's even higher, but I'll get to that in a little bit. Or rollbacks. And about that open S3 bucket, so we still have the broken access controls on the OF top 10 at number 1. Mind you, security misconfigurations is at 2. So we're doing exceptionally well. But if you think you've got everything tied down, you know, your buckets are all locked up, collectively, we pushed over 23 million secrets onto public GitHub repositories over last year alone. And we're not doing that well with private repositories as well. So, yeah. All right. Now, where do we want to be? So imagine again that it's that same Monday morning, but this time you're starting on a new project, and you're already delivering your first meaningful commit that very same morning. No extensive rework, no security people knocking on your door, no onboarding issues, no runtime issues. That's where we want to be, right? Sounds ideal. We want to be one of those elite engineering teams. All right, but what does that actually mean? So I got some numbers for you. Is anyone here familiar with DORA? I'm not talking about the little girl with the monkey in the boots, right? I'm also not talking about some European legislative piece, right, for you security people. Now, this is a long-running research program from Google about operational excellence in software delivery. And so this is a survey. It's been running for 10 years already. And since I have you all here, we can kind of repeat the survey. So I'll ask you about the first category. That's the change lead time. That's how long it takes for a commit to go all the way into production. So I want to ask you to raise your hands again. and tell me, how long does it take your teams? Months? From a commit all the way to production? No? Are you all good? Sometimes. There you go. All right. Weeks? Yeah, that's more realistic, right? All right, is there anyone who can just pull this off within a day? Oh, well, you're elite, man. You should be up there. We should be there. Right. Now, but that is indeed how it is. Like, we have the elite teams taking under a day to do this, then moving towards the low performance, taking weeks up to months. I'm sorry, mate. But we get to improve. That's why you're here, right? All right, second thing is deployment frequency. This is how often you would actually deploy to production. So are we talking about once every few months again? I would expect the same hands. There you go. Once every few weeks? Yeah. All right. So we got the elite teams here just doing it like on demand. Like whenever you need it, push there to production. And by the way, why is this metric important? And this is one which is important also with regards to AI. This is talking about how small your commits actually are. Like, the smaller the commit, the lower the risk, the less impact on production. And the funny thing is with AI, you usually make very large commits, so it's cool. All right, I'll spare you the other metrics for the survey, but I'll tell you the failed deployment recovery. So this is how long it will actually take you to go from that bad situation onto your normal operation again. And you have the elites typically taking upwards of a day, where the low performers taking maybe days to weeks to months just to restore a service. And this is, of course, impacting your customer experience. And the last bit, the change fail rate, that's actually the metric I had on the other slide. So it's 45 to 60% of all those production deployments either require rework or rollbacks. That's pretty significant. And you have the elite teams typically around 15%. So, all right, that's nice numbers, right? So how do we get there? So this is where dev containers help remove the potholes to actually make you go fast. They enable you to create a consistent development environment with embedded quality controls, with security checks, like having your static analysis tools, you've got your linters that you can integrate, you've got your code formatters, your scanners, all that can be integrated within your dev container. But it's also the tool to quickly help you adopt other tools like Amazon Q Developer, and that helps accelerate your teams. It accelerates your onboarding. One final note on this, though, and if you read the Dora reports, they'll tell you there is no silver bullet which will improve everything. But dev containers will definitely help you unlock those elite practices. So that's how you should view this. All right. And that's what we're going to talk about today. We're going to talk about how we can use those dev containers to actually make our AWS projects, our deployments, all the better. Just accelerate those deployments. And on the first bit, Matteo is going to explain a little bit about the anatomy of a dev container. So what are the key components there? How is the configuration built up? In the second bit, he's going to talk about how you can integrate Amazon Q Developer, inside a dev container configuration and enable these complex workflows, which go over the rule-based stuff, which is usually in your static analysis tools. The third bit is because we also want to scale, we want to enable some kind of modular system within those development containers, and luckily, there's development container features, which are like these repeatable building blocks. So instead of adopting it just for one image, you can use it for the other, and for the other, and for the other, right? Now, to scale even further, we'll also talk about creating a pipeline for these development containers. So it's no longer just you building it on your local laptop, it's building it inside a pipeline, and to make sure these images are available, images and features, for anyone who needs them. And before I hand over the floor to Matteo, again, I'd like to remind you, it's an interactive session, so if you do have a question for us, pop one in. Matteo?
Thank you, Chris. So, as you very well said, we as consultants need to be right the first time, all the times. And this means that we need to take care about all the little problems, all the little bits before creating an artifact for our customers, right? This means that we might want to discover all of the problems before a CI/CD pipeline starts and find that, right? So it means that we want to shift left all the checks into our development environment. So what do we have here today? So here I have Visual Studio Code, right? Are you familiar with that? I think so. But how do we do shift left these checks? So we use, it's pretty easy, right? Use dev containers. So we create dev containers to standardize our development environment across developers in the team, across teams, so we all get the same environment, okay? What is a dev container? You can guess it. It's a container, right? So as a container, we need two main things to use it. One is the container runtime. You can use Docker, you can use Finch, you can use Rancher, you can use whatever container runtime you prefer. And the second thing is an IDE that is compatible with dev containers, like VS Code, IntelliJ, and many others. So let's get into the demo. We have here a CDK application, right? You might be familiar with that. It doesn't matter, right? It's not the scope of the session today. We're not going to say how CDK works, how to deploy a stack with CDK. Doesn't matter. Just let's take it as a Python code. We want to create the environment to be effective developing the Python code, right? In this case. To do that, we need to create a dev container. And the dev container needs to be inside, the dev container configuration needs to be inside a specific path. It needs to be inside .devcontainer/devcontainer.json, right? That's the config file. And the config file could be very easy or a bit more complex. In this case, you see that there is only one line. It's quite easy, right? So this is the image that the container runtime will use to create a container that the IDE will be connecting to. As you see on the screen, there are also other lines commented out, and let's go through them quickly. So the first one is one example of a lifecycle command. With dev containers, we can use the lifecycle events. It means that we can run commands, scripts, based on the lifecycle event, which means, for example, when you create a container, after the creation, it's run a command. When you attach to the container, which is similar to when you open the laptop in the morning and you start developing, so you attach to the development environment, it might run another set of commands. Then you can also configure your IDE, setting, for example, the tab size in this example, or maybe installing some extensions. Lastly, we can add features. We will talk about features in more details later during the session, but in this case, I want to show you how easy it is to create the container. So we have this configuration file, and then we just do reopen in container, and it will detect that the dev container JSON file is there. It will read it, and it will create a container that the IDE will be connecting to. As you see here, I'm running a Mac. I'm running on a Mac. And if I run here uname -a, I'm in Linux. This is because I'm running inside the Debian container. Okay. But you know, this is a very basic image. We want to have an effective environment to develop. So I've prepared another example. As I said before, the dev container JSON file might be a bit complex. So in this example, it is a bit more complex. Instead of using a single image, I'm referring to a Docker file inside the .dev container directory. It's important. That Docker file is going to build an image locally, right? As we are talking about a Python application, we need the Python VM, right? And the Python VM is based on the host that you are running on. So for example, if I create the Python VM on macOS, it's going to be different from the one that is going to be created on Linux, right? So we want to create a VM all the times that we create the new container, because otherwise, when you clone the repo inside the container, it might have a different virtual environment, and it could not work. The other things that we are adding here are pip audit and pip licenses as part of our security guidelines, and we run those commands when we open our laptop, so when we connect to the container. I'm also adding some configurations for the IDE. So for example, I'm defining the Python default formatter to black formatted that is going to be installed as an extension together with PyLint and Flake8. Of course, you can add all the extensions you want. You can add formatters, linters, all the security tools you prefer. I'm also adding some features. In this case, I'm adding the common utils feature and the Python feature. All of them are going to install other tools as part of the feature itself. And remote user is the user that is inside the container, and it's connected to the user on your laptop. Okay. So as you see here, I'm starting from let's say, a vanilla VS Code. There's nothing in it except the dev container extension. Of course, otherwise it doesn't work. And if we connect to the container now, it will load this configuration that has quite a big amount of settings. And you will see popping up on the left-hand side some extension icons. You see Python now, and also testing, right? So it's also running the commands that you have seen before, the post attach commands and the onCreate commands, just to be sure that, for example, the licenses are up to date with the packages that we are using inside this project, right? As I have added the Python feature, we are going to see that the virtual environment is loaded automatically. And we should see now, yeah, they are. Here they are. Some problems in this file. So I thought to have written a good file. No, I hadn't. So we need to refactor this file. Otherwise, the CI/CD pipeline would fail, right? Because in the CI/CD pipeline, we will have all the checks. So let's go and refactor these. To refactor these, we need to add Amazon Q, right? To add Amazon Q, we need to add the extension. So if you don't remember the extension ID, I don't, okay? So I just search Amazon Q, and then you can simply do add to dev container.json. What it does is you will see down here, right? So you can dynamically update the JSON file. Then, do we want to use Amazon Q as it is? No, we don't. We want to add some context to Amazon Q in order to perform better. To do that, we create an MD file that is going to be used as a rule for Amazon Q developer, and we want to make it inside the dev container, right? So we need to add it to the .dev container directory, and we also need, I don't want to write it down, so I'm gonna copy it. Where is it? Here. So we add this command to the post create. It does create .amazon Q rules at the root of the project. It's a mandatory path, okay? And then it copies the MD file into that directory. What do we have in the MD file? So we are setting just general rules. We want to have all the files, all the Python files with the header, with the copyright and the license, right? We want to have all the functions with the docstring. We want to have all the Python files to be compliant with BEP8, right? It's just an example. You can add whatever you want. Okay, so now we need to rebuild the container in order to have this inside the container. So we do rebuild container. It's gonna, let's say, start from scratch and rebuild the Docker image. Most probably it's cached, right? And then install all the features, run all the post create commands, including the Amazon Q command. And you see here, it's gonna rebuild the Python environment. It might take a while.
Did you save it?
Oh, damn it.
It's a classic.
It's not gonna solve all the problems. Some problems are between the chair and the laptop, right? Yeah, right. Or just enable auto-saving. So, conscious of time, I'm gonna comment this out because, as I said before, it's important to create the venv, right? Or, in this case, as we are starting from the container already, it's not mandatory to rebuild it. So I'm gonna
maybe save that one as well.
I'm gonna rebuild the container. It should take less time. Okay. Thanks, Chris. Okay. It's building. Fantastic. We will see that now it's going to run the, you see here, the Amazon Q, the copy of Amazon Q rules inside the directory. And if we refresh, we see Amazon Q here, right? With the best practices file. And also, we should see Amazon Q. Fantastic. We have Amazon Q. We need to log in. Let's log in. Proceed to browser.
The key thing here is that the dev container is kind of independent from the repository. So you tie them two together, and then the repository gets whatever context for Amazon Q you define in that dev container inside the repo. So you can centrally define a context and manage that context. And that's really powerful.
Okay, so now we can refactor the Python file. So let's ask Amazon Q to do that. Refactor. It's going to take the entire file. And as a context, we see that we have also the best practices MD file, right? And as you see here, I'm having the new comments at the top of the file, the new header, and it's well formatted. We have all the module doc strings ready to go. Most probably, the CI/CD pipeline won't fail. But we have done it here, locally, inside this only container, right? It doesn't scale. We need to create this building block that could be shared between people. And to do that, we switch to features. So features are the building blocks that can be packaged and be shareable between developers and teams, between other dev containers at the end, right? So to do that, we need to create a folder inside dev container named as the feature. So that is going to be the feature name. And as this is going to take a while to build, I'm going to do that. One thing I want to highlight is that, as you see here in the config file, I've commented out the copy Amazon Q rules that we used before. So we don't need that anymore, as we don't need Amazon Q anymore, because it's going to be part of the feature. So I'm going to rebuild it, including the local feature. So you can reference local features this way. You just provide a path, right? And it's going to be included inside the dev container. So let's switch here on the terminal. I'm going to show you what files we need to create a feature. Essentially, we need two files, at least two files. One, it's named install.sh. And by the way, these two files need to be named this way. Okay, it's important. And the install.sh is just an installation script that will install the tool you need, essentially. In this case, it's going to create the Amazon Q rules. The other important file is the dev container feature JSON, right? This is the configuration file for the feature. It requires a semantic versioning. You can use the same blocks as you used inside the dev container.json file for the dev container itself. So for example, here I'm installing the extension Amazon Q, as we were doing before, inside the container, inside the dev container. And also, I'm moving the Amazon Q rules inside the repository. That's an important thing, because otherwise, when you create the container, you create the rules, but the repository is not mounted inside the repository yet. So when it mounts inside, it will override everything, right? When you mount a file system over a mount point, if you have something in that mount point, won't be accessible anymore. So these are the two important things, the two important files. Let's see if it's built. Oh yeah, it's built. Perfect. So now we see that we have Amazon Q now here as part of the repository, and it's the new one. I've added the label inside the file of the feature, right? You see here, this is actually the same file we have in the actual .amazonq rules path. Okay, so we have created finally the feature, but it's still local. So this is the development process to create a feature that is going to be reusable afterwards, right? To create the reusable feature, we need to package and create an image for that. So we have created a factory for that. Chris will tell you more about it later. And I want to show you one thing that is the last one, that is, let's say, the outcome of that factory. So we have seen the dev container config file, the feature, and if we condense everything together, we create one image, right? And that one image is this one. So you can think, I mentioned before, about building blocks. You can have dev containers, features, you can put different things together, and you can create one single image. It's quite easy for a developer to create an environment, just creating the configuration file with one line, right? So you can provide developers this thing. As you see here, I'm starting again from a plain VS Code project, but I have this image that is actually the union of everything that we have seen today. So if we reopen that in the container, it will check the config file that has only the image, right? But it's gonna create everything for us. We will see extensions, we will see post-create commands, post-attach commands, Amazon queue context, everything just with a one-line config. So essentially, this is what we usually do when we develop. And Chris, over to you again.
Thank you, Matteo. Before we do, and please switch the screen for me, if you can. So yeah, we're kind of approaching the end of the session already, but we want to leave you with something more tangible. Indeed, that container that Matteo just pulled in that was built remotely with Code Pipeline. And this is a very high-level diagram. So we built a CDK pattern for a pipeline, which is essentially a warehouse with stateful resources and all these different pipeline stacks per image and per feature, right? And the way this works is we just copy a configuration, or you copy a configuration onto S3. That will trigger EventBridge, kickstart the pipeline for each image or feature that you actually push to S3. And that will deliver to ECR. And from that point on, you can either then pull it into your project like Matteo did, or you can use Crane to bring it over to your repository, which is available to your employees or to your teammates. Or you create this landscape, this modular landscape of a base container with an extended container, which uses that and which brings in features that you also have managed by other teams or whatnot. And that's a little bit how that is. It's published on AWS samples. I'll give you the QR code is on the other slide. Is there any questions on this? So this is also a multi-architecture image. So it builds it for Mac and for PC. Again, using AMD 64 and ARM with Graviton. So it'll run on all the machines. Cool.
Maybe we can also show how to create a feature with that pipeline, right?
Oh yeah, well, let's do that. Do we use a recent package?
Yeah. Okay. So as Chris mentioned, we have created a repository that is public on AWS samples, and there is an example for Kiro CLI. So we have created the Kiro CLI feature that can be added to the dev container. Let's do it together. So to do that, we need to create a new folder here, Kiro CLI, and then install sh, right? Here we are going to put the code to install Kiro CLI. So what we usually do when we develop features, we understand how to install that package that we want to do. So we go and check Kiro. We do here, CLI. Oh, it's pretty easy, right? So we copy that single line. But that single line is going to install that with the root user. We want to install that with the remote user inside the container. So I'm not going to write everything from scratch. So we have it already. You have it already. It's public. So we are going to add this code here. OK. Let's gonna create the other file. Dev container dot feature dot JSON. And in here, we need to put the config file. So this one, essentially. OK, it's more readable here. So we define the name, the ID, the semantic versioning, the description, and let's say a constraint. So it's going to be installed after the other feature. That, if you remember well, it's part of the dev container config file. So we do this, and to package everything up, we need to, so here we are inside the dev container folder. We see the Kiro CLI directory. We go into there, and we have those two files. So we need to zip this content into a zip file, and then we are going to upload S3 API. We are going to upload this zip file into the S3 bucket that Chris mentioned before. That was part of the architecture as an entry point, right? So this one is going to be pushed to the S3 bucket. This is the version ID. And if we wait a bit, it's going to be built by the pipeline. We have created it already, right? So what we can do is just add the features, and I'm going to take this repository. It's the same without the dictionary, right? It's pretty difficult doing that here. OK. OK. Perfect. What am I missing? The comment.
You gotta change the name.
Yes.
Like it's not a base image.
Where? Yeah, saved. Thank you. OK. I need to change features and Kiro CLI. We name it this way, right? So we save again, and
you're missing it.
We rebuild. Okay, it might take a while, but at the end we are going to have the same environment as before with Kiro CLI installed. So we are going to check that from the terminal if I didn't do any typo, right? Okay, it's running the pip licenses because we are building again, and we are not just attaching to the container. Okay, come on. In the meantime,
maybe you're already able to open up a terminal.
Any other questions?
Give it a shot.
Let's see. Kiro CLI, we have it. Right. Loading the VM, Kiro CLI, help. Yeah, we have it. So this is online on ECR, and it can be shared with everyone.
Yeah, so this is really easy, right? This does give you a rather large container, and you do need to look at how Kiro actually looks. I did this with Amazon Q Developer at first, but it was an unstripped binary, so it was massive. So, but yeah, this unlocks like really powerful patterns. If you want to have like pre-commit hooks using Kiro as well, or you want to use Kiro to give you some insights on those, on your commit, just your commit messages. You're doing changes and you want a certain format. that's how you can use this as well. So that's, yeah, thank you. Awesome. And then I promised the last slide is also featuring the QR code for that repo. And yeah, I mean, you've got a full week ahead of you, so make good use of it. Enjoy your time here at re:Invent.